8th grade, Unit 3, Lesson 1, Understanding Proportional Relationships. Number 1. Priya jogs at a constant speed. The relationship between her distance and time is shown on the graph. Diego bikes at a constant speed twice as fast as Priya. Sketch a graph showing the relationship between Diego's distance and time. In 2/10 of an hour, Diego jogged 2 miles. In 2/10 of an hour, Priya jogged only 1 mile. Number 2. A U-Pick blueberry farm offers 6 pounds of blueberries for $16.50. Sketch a graph of the relationship between cost and pounds of blueberries. First, I'm going to build a table. I have pounds on the left and dollars on the right. They tell us that you get 6 pounds of blueberries for $16.50. 6 pounds divided by 6 equals 1 pound. Since I divided the pounds by 6, I need to divide the dollars by 6. $16.50 divided by 6. $16.50 divided by 6 is $2.75. So 1 pound would cost $2.75. The pounds for blueberries, 0, 10, 20, 30, 40, doesn't jive very well with the pounds that I have in my table. So I'm going to need to change my table a bit. 10 pounds of blueberries and 40 pounds of blueberries. 1 pound times 10 equals 10 pounds. Since I multiplied the pounds times 10, I need to multiply the dollars times 10. So $2.75 times 10 equals $27.50. 10 pounds of blueberries for $27.50. 1 pound times 40 equals 40, and since I multiplied the pounds by 40, I need to multiply the dollars by 40. So $2.75 times 40. $2.75 times 40 equals 110. So 40 pounds of blueberries for $110. 10 pounds for $27.50. $27.50 would be somewhere between 24 and 36, a little bit closer to the 24. And so I can put my point right about there. 10 pounds and $27.50. This point represents 10 pounds and $27.50. 40 pounds and $110. So $110 would be just above the $108, and I would put my point there, and this point represents 40 pounds at $110. This line represents the relationship between pounds of blueberries and the cost in dollars. Number 3. A line contains the points -4 and 1 and 4 and 6. Decide whether or not each of these points is also on the line. We're going to find the slope. 6 minus 1, or the y value minus the y value, equals 5. That's the rise. The difference in the y value represents the rise of the slope. 4 minus a -4. That's the difference of the x values. 4 minus a -4. That's the same as 4 plus 4. And 4 plus 4 equals 8. That's the run. So the rise over run would be 5 over 8, or 5/8. 5/8 is also 5 divided by 8, which would be the decimal 625 thousandths, or 0.625. So now we're going to find the slope of the coordinates 4 and 6 and the coordinates 0 and 3 and 5/10. 6 minus 3.5, that equals 2.5. So the rise would be 2.5 and the run would be 4 minus 0. 4 minus 0 equals 4. 2.5 divided by 4, or 2.5 over 4. That's equivalent to 5/8, which is also equivalent to 625 thousandths, or 0.625. The coordinates for A would be yes. That point would be on the same line. B, 6 minus 11 equals -5 for the rise. And the run would be 4 minus 12, and 4 minus 12 equals negative 8. So the rise would be negative 5, and the run would be negative 8. Negative 5 divided by negative 8. That's the same thing as 5 divided by 8, or 5/8, because a negative divided by a negative is a positive. And of course 5/8 is equivalent to 5/8. So the coordinates 12 and 11 would also be on the same line. C, 6 minus 50 equals negative 44, that's the difference in the y coordinates, over 4 minus 80, that's the difference in the x coordinates. So negative 44 over negative 76, or negative 44 divided by negative 76. Again, a negative divided by a negative is the same thing as a positive. So it's also equivalent to 44/76, or 44 divided by 76. And that equals 0.57894, and it continues on. So that obviously is not equivalent to 0.625. So coordinates 80 and 50 will not be on the same line. D, 6 minus 2.875, and 6 minus 2.875 is 3.125, or 3 and 125 thousandths. So the rise would be 3 and 125 thousandths over 4 minus a negative 1. And 4 minus a negative 1 is the same as 4 plus 1. So the run would be 5. 3 and 125 thousandths over 5, or 3 and 125 thousandths divided by 5. That equals 625 thousandths, or 0.625, which is equivalent. It has the same slope. Yes, the coordinates negative 1 and 2 and 875 thousandths would be on the same line. Number 4. The points 2 and negative 4, x and y, and a and b all lie on the same line. Find an equation relating x and y. I'm going to use this point because it lands on the x coordinate 2 and the y coordinate negative 4. I'm not going to use this one because it doesn't land directly on a whole number. I am going to use this one because it lands directly on the whole number 6 on the x coordinate and negative 1 for the y coordinate. I'm going to use this one also because it lands on the x coordinate whole number 10 and the y coordinate whole number 2. Here's a rise of 3 and a run of 4. That means that the slope is 3 over 4, or 3/4 slope. And again, here we have a rise of 3 and a run of 4, confirming that this line has a slope of 3/4. An equation would be y minus the y coordinate of negative 4. And y minus negative 4 is positive 4. So y plus 4 over the difference of the x coordinates, x minus 2. That could be written as y plus 4 over x minus 2 equals a slope of 3/4. Like, comment, share, and subscribe. Scroll along the bottom with your cursor. This shows where number 1 is, number 2, number 3, and number 4. Quick and easy way to jump from problem to problem for your convenience. There's another way you can easily jump from problem to problem. Look in the video description section and find the table of contents. Click on the timestamp next to the problem that you'd like to jump to, and it takes you straight to that problem in the video. 8th grade Open Up Resources, Illustrative Mathematics, Unit 3, Lesson 2, Graphs of Proportional Relationships. Problem number 1. The tortoise and the hare are having a race. After the hare runs 16 miles, the tortoise has only run 4 miles. The relationship between the distance x the tortoise runs in miles for every y miles the hare runs is y equals 4 times x. Graph the relationship. First, I think I'll make a table to get some coordinates. The x value will be on the left side of the table, and the y value will be on the right side of the table. Remember, all the y values will be 4 times greater than x. What's 4 times greater than 0? 0. What's 4 times greater than 1? 4. What's 4 times greater than 2? 8. If you look closely, you can see that I plotted each of these sets of coordinates, and they all fall on this line. The horizontal axis, or the x-axis, represents the distance that the tortoise runs in miles, and the vertical axis, or the y-axis, represents the distance the hare runs in miles. Problem number 2. This table shows a proportional relationship between the weight on a spring scale and the distance the spring has stretched. A. Complete the table. We have distance in centimeters on the left side of the table and the weight in newtons on the right side of the table. In the first proportional relationship, we can say that 28 newtons pulls the spring a distance of 20 centimeters. 28 divided by 20 equals 1 4/10. The proportional relationship is 1 4/10, which means 28 is 1 4/10 times larger than 20, or 20 is 1 4/10 smaller than 28. That means that in the next proportion, 55 is 1 4/10 smaller than the unknown weight. 55 times 1 4/10 equals 77. So we know that the unknown weight is 77. 140 is 1 4/10 times larger than the unknown distance. So 140 divided by 1 4/10 equals the unknown distance. The unknown distance is 100 centimeters. And the last one, the distance is 1. 1 is 1 4/10 times smaller than what number? 1 times 1 4/10 equals 1 4/10. When the distance is 1 centimeter, the weight in newtons is 1 4/10. And 1 4/10 is equivalent to 14/10. Any answer that's equivalent to 1 4/10 or 14/10 would work. Even 14/10 can be reduced or simplified to 7/5. So 7/5 would work. In fact, 20 over 28, 55 over 77, 140 over 100, and 7 over 5 all equal 7/5. That's what makes their relationships proportional. The weight in newtons is 7/5 times greater than the distance in centimeters. B. Describe the scales you could use on the x and y axes of a coordinate grid that would show all the distances and weights in the table. If I were to create a graph that represented all these values, I'd have to make sure that I made it large enough to fit the distance from 0 to 100. And the distance would be my horizontal axis, or my x-axis. And I'd have to make sure my graph was tall enough that I could represent up to 140 newtons in the weight category. Weight would be represented as my vertical axis or my y-axis. Problem number 3, from 8th grade, Unit 2, Lesson 6. Find a sequence of rotations, reflections, translations, and dilations showing that one figure is similar to the other. Be specific. Give the amount and direction of a translation, a line of reflection, the center and angle of a rotation, and the center and scale factor of a dilation. Wow, that's a mouthful. It sure sounds like a lot of stuff. I'll do the best I can. I'll start by using A as the center point. Looking carefully, I can see that D prime is exactly 1 unit away from center point A, and point D is 3 units away from center point A. The figure on the left is a dilation that's 1/3 scale of the figure on the right. That means that the figure on the left has side lengths that are 1/3 the length of their corresponding side lengths from the figure on the right. Since point D is 3 units away from point A, and I'm making a dilation with a scale factor of 1/3, 1/3 of 3 is 1. So point D's new location will be 1 unit away from point A. Let's move point E. Originally, point E was 6 units away from point A, and 1/3 of 6 is 2, so its new location will be 2 units away from point A. Let's move point C. Point C's original location was 6 units away from point A, and 1/3 of 6 is 2, so its new location will be 2 units away from point A. Let's move point B. Point B's original location was 9 units away from point A, and 1/3 of 9 is 3, so its new place will be 3 units away from point A. Connect the points and you can see the dilation with the scale factor 1/3. In its current position, it looks like a reflection of the dilation on the left. Next, I'll do a rotation. Look at point E on the figure that we just drew. It's 2 units away from point E prime on the dilation to the left. Let's move point E clockwise 2 units, and let's move all the other points clockwise 2 units. After moving them 2 units clockwise, we can draw the lines connecting the points, and we will see our figure after a clockwise rotation of 2 units. Now I've been calling them units just to make it easy, but each one of those units is worth 15 degrees. The reality is, it was a 30-degree clockwise rotation. And with this rotation, we've created a reflection across centerline A and E. Problem number 4 from 8th grade, Unit 2, Lesson 6. Consider the following dialogue. Andre said, "I found 2 figures that are congruent, so they can't be similar." Diego said, "No, they are similar. The scale factor is 1. Who is correct? Use the definition of similarity to explain your answer." Here's a definition of similar. 2 figures are similar if one can fit exactly over the other after rigid transformations and dilations. The 2 figures are congruent, meaning they are the same size and shape. And after a rigid transformation or dilation, with the scale factor 1, they would be similar. So I would agree with Diego when Diego says, no, they are similar, the scale factor is 1. Eighth grade Open Up Resources, Illustrative Mathematics, Unit 3, Lesson 3, Representing Proportional Relationships. Glossary terms. Rate of change. The rate of change in a linear relationship is the amount y changes when x increases by 1. The rate of change in a linear relationship is also the slope of its graph. In this graph, y increases by $15 when x increases by 1 hour. The rate of change is $15 per hour. Time in hours is the horizontal axis or the x-axis, and the amount earned in dollars is the vertical axis or the y-axis. Let's take a closer look to see how this line represents the rate of change. I'll put a point at the coordinates 2 and 40. 2 units to the right of the origin along the x-axis and 40 vertically on the y-axis. I'll place the second point at coordinates 6 and 100. The first point represents 2 hours and $40, and the second point represents 6 hours and $100. It says that the rate of change is $15 per hour, so let's test that out. Let's start from the second hour. $40 plus $15 equals $55. $55 plus $15 equals $70. $70 plus 15 equals $85. And finally, $85 plus $15 equals $100. So far, it checks out just fine. One good question might be, why does the second hour start at $40? One would think that from 0 to 1 hour would be $15, from 1 hour to 2 hours would be $30. But this graph shows that 2 hours is at $40 and not $30. So let's see if we can figure this out. 55 minus 15 is 40, and 40 minus 15 is 25, and 25 minus 15 is 10. The line on this graph shows that 0 hours is worth $10. Here's a closer look. At 0 hours, the line starts halfway between $0 and $20, which is $10. It's kind of like getting $10 just for showing up, then earning $15 per hour. The rate of change for this graph is $15 an hour, or 15 to 1, which is the ratio of 15 to 1, and can be represented as 15 over 1 or 15 divided by 1. And 15 divided by 1 is 15, so the slope of this line is 15. Lesson 3 practice problems. Number 1. Here is a graph of the proportional relationship between calories and grams of fish. A. Write an equation that reflects this relationship, using x to represent the amount of fish in grams and y to represent the number of calories. Located at the bottom of the graph, along the horizontal axis or the x-axis, is grams of fish. The x-axis represents grams of fish. Located along the vertical axis or the y-axis is the number of calories. Take a close look at the circled section along this line. The line goes right through the crosshairs with 100 along the x-axis and 150 along the y-axis. I'm going to use this to help me figure out more about this graph. I'll use these coordinates to get me started. So the value for x is 100 when the value for y is 150. If I make the value for x 10 times smaller, that would be 10. To keep it proportional, I have to make the value for y 10 times smaller, and that would be 15. So when x is 10, y would be 15. I can make the value of x 10 times smaller, and that becomes 1. And now I make the value for y 10 times smaller, which is 1 5/10, or 1 1/2. These x and y values are coordinates for points on this line. The rate of change is that y is 1 1/2 times larger than x. Look at our first example. When x is 100, y is 150. 150 is 1 1/2 times larger than 100. Look at the last example. When x is 1, y is 1 1/2, or 1 5/10. That's another example showing that y is 1 1/2 times larger than x. So an equation that could represent that would be y equals 1 1/2 times x, or 1 5/10 times x, or y equals 3/2 times x. B. Use your equation to complete the table. I left the equation and some important information on the very top to remind us. Y is 1 1/2 times larger than x, and the equation is y equals 1 5/10 times x, or y equals 3/2 times x. Remember, grams of fish is x, and number of calories is y. It's the number of calories that will be 1 1/2 times larger than the number of grams of fish. Let's start with 1 gram of fish. What's 1 1/2 times larger than 1? 1 5/10, or 1 1/2. This means that 1 gram of fish has 1 1/2 calories. Let's look at 1,000 grams of fish. What is 1 1/2 times greater than 1,000? 1 1/2 times 1,000 is 1,500, or 1,500. 1,000 grams of fish has 1,500 calories. This last one starts with calories, so instead of multiplying by 1 1/2, we have to divide by 1 1/2. 2,001 calories divided by 1 1/2 equals 1,334 grams of fish. 1,334 grams of fish has 2,001 calories. Problem number 2. Students are selling raffle tickets for a school fundraiser. They collect $24 every 10 raffle tickets they sell. A. Suppose M is the amount of money the students collect for selling R raffle tickets. Write an equation that reflects the relationship between M and R. The amount of money collected is 24/10 larger than the amount of tickets sold. 24/10 can be reduced or simplified to 12/5. The amount of money collected is 12/5 larger than the amount of tickets sold. This sentence will help me write an equation that reflects the relationship between M and R, with M representing money collected and R representing raffle tickets sold. The equation I came up with is M equals 12/5 times R, or M equals 12/5 R. B. Label and scale the axes and graph this situation with M on the vertical axis and R on the horizontal axis. Make sure the scale is large enough to see how much they would raise if they sell 1,000 tickets. Let's graph this situation with money on the vertical axis or the y-axis and raffle tickets along the horizontal axis or the x-axis. Remember, our equation is M equals 12/5 times R, or M equals 24/10 times R. Or this equation. See if you can figure it out. M equals what number divided by 1,000 times R? Or M equals 2,400 divided by 1,000 times R. 12/5, 24/10, and 2,400 thousandths are all equivalent fractions. Their equations all have the same meaning. I think I'll use M equals 24/10 times R and M equals 2,400 thousandths times R to help me come up with coordinates to plot points on this graph. I'm going to label the origin, which is the 0 value for x and the 0 value for y. Remember, according to my formula, R is always going to be 24/10 times larger than M, which means the x value will always be 24/10 times larger than the y value. Let's say the x value is 10, then the y value must be 24. This makes an ordered pair, or a set of coordinates. The x value is 10 and the y value is 24. I'll plot a point to represent 10, 24. Let's just go straight to selling 1,000 tickets. The x value is 1,000, the y value is 2,400. I've plotted those points, now we can draw the line that this formula represents. Both the slope and the rate of change is 24/10, or like we said earlier, 12/5. Problem number 3 from 8th grade, Unit 2, Lesson 10. Describe how you can tell whether a line's slope is greater than 1, equal to 1, or less than 1. I'll use a graph to illustrate this point. Let's say that the horizontal base of a triangle is 4 units and the vertical side of the triangle is 6 units. This would create a slope of 6/4 and can be simplified or reduced to 3/2. If the vertical length is greater than the horizontal length, then the slope is greater than 1, like this example. Let's try another one with a horizontal length of 4 and a vertical length of 4. This slope would be 4/4, or 1. If the vertical length and the horizontal length are equal, then the slope is 1, like in this example. In this last example, the horizontal length is 6 and the vertical length is 2. This would have a slope of 2/6, which can be reduced or simplified to 1/3. When the vertical length is shorter than the horizontal length, the slope is less than 1, like in this example. Problem number 4 from 8th grade, Unit 2, Lesson 12. A line is represented by the equation y over x minus 2 equals 3/11. What are the coordinates of some points that lie on the line? Graph the line on graph paper. The equation is important. Y over x minus 2 equals 3/11. This is actually telling you the value for y. When x is 13, y equals 3, because 13 minus 2 equals 11. When the value for x is 13, then the value for y is 3. Now we have our first set of coordinates, or ordered pairs. The x value would be 13, and the y value is 3. You can rewrite this equation as y equals 3/11 times x minus 2. Let's use this ordered pair 13 and 3. Let's plug in the x value, that's 13, and plug in the y value, that's 3. Now the equation reads 3 equals 3/11 times 13 minus 2. 13 minus 2 is 11. Now the equation reads 3 equals 13/11 times 11. And 13/11 times 11 is 33/11. 33 divided by 11 is 3. 3 equals 3. Let's use our new equation to create another set of ordered pairs. I'll use a t-chart to illustrate what's going on. Let's use 2 as the value for x. Now to find the value for y when x equals 2, we'll just plug the 2 into the equation. Y equals 3/11 times x minus 2. This is where we're going to plug the 2 into where the x is. Now it reads y equals 3/11 times 2 minus 2. And 2 minus 2 is 0. So 3/11 times 0 is also 0. For this equation, when the value for x is 2, the value for y will be 0. Now we have our second set of ordered pairs. The x value is 2 and the y value is 0. We need at least 2 sets of ordered pairs to graph a line, and we have those sets, so let's start graphing. Move 13 units to the right on the horizontal axis, which is the x-axis, and 3 units vertically on the y-axis. Now we can plot our point. Before we can draw our line, we need to plot our next set of coordinates. Starting at the origin, like always, for the x value, we need to move 2 units to the right, and for the y value, 0 units, so we don't have to move up at all. So we can plot our point right there at 2 units to the right of the origin. Now we can draw the line that represents the equation and these 2 sets of ordered pairs. Like, comment, share, and subscribe. Scroll along the bottom with your cursor. This shows where number 1 is, number 2, number 3, and number 4. Look in the video description section and find the table of contents. Click on the timestamp next to the problem that you'd like to jump to, and it takes you straight to that problem in the video. 8th grade Open Up Resources, Illustrative Mathematics, Unit 3, Lesson 4, Comparing Proportional Relationships. Problem number 1. A contractor must haul a large amount of dirt to a work site. She collected information from 2 hauling companies. Easy Excavation gives its prices in a table. Happy Hauling gives its prices in a graph. A. How much would each hauling company charge to haul 40 cubic yards of dirt? Explain or show your reasoning. Let's start by looking at Happy Hauling's graph. I noticed that the line on the graph passes through the crosshairs at x value 2 and y value 50. I'll put a point at x value 2 and y value 50. This tells me that 2 cubic yards of soil costs $50. That's a ratio of 2 to 50. They're asking us to haul 40 cubic yards of soil. That's going to be a ratio of 40 to 1,000. Happy Hauling Services would charge $1,000 to haul 40 cubic yards of soil. Now let's look at Easy Excavation's table. The table shows that 20 cubic yards of dirt costs $490 to haul. We can easily multiply that 20 to turn it into 40. 20 times 2 equals 40 cubic yards of dirt, and 490 times 2 equals $980. At Easy Excavation, it costs $980 to haul 40 cubic yards of dirt. B. Calculate the rate of change for each relationship. What do they mean for each company? I think we're just comparing the rate of change for each company. The slope for Happy Hauling's graph is 25 units up, or the rise is 25 units, and 1 unit to the right, or a run of +1, making the slope and the rate of change 25 over 1, or 25. The rate of change for Happy Hauling Service is $25 per cubic yard. Now let's take a look at Easy Excavation's table. 8 divided by 8 equals 1, so we have 1 cubic yard. And 196 divided by 8 equals $24.50. So 1 cubic yard costs $24.50. Easy E's rate of change is $24.50 per cubic yard. C. If the contractor has 40 cubic yards of dirt to haul and a budget of $1,000, which hauling company should she hire? Explain or show your reasoning. I notice in Easy E's table, 20 cubic yards of dirt cost $490 to haul. I can easily multiply that 20 times 2 to make 40. Since I multiplied the 20 cubic yards of dirt times 2, I have to multiply $490 times 2, which is $980. So through Easy E, you can haul 40 cubic yards of dirt for $980. Let's look at the graph for happy hauling. If hauling 2 cubic yards of dirt costs $50, then hauling 40 cubic yards of dirt would cost 20 times that amount. Since 2 times 20 equals 40, and we have to haul 40 cubic yards of dirt. Since we multiplied cubic yards of dirt by 20, we need to multiply the cost in dollars by 20. 50 times 20, or 20 times 50, equals 1,000, or $1,000. To haul 40 cubic yards of dirt for happy hauling service, it cost $1,000. So to save a little bit of money, she should choose Easy Excavation, which comes in $20 under her $1,000 budget at $980. Problem number 2. Andre and Priya are tracking the number of steps they walk. Andre records that he can walk 6,000 steps in 50 minutes. Priya writes the equation y equals 118x, where y is the number of steps and x is the number of minutes she walks, to describe her step rate. This week, Andre and Priya each walk for a total of 5 hours. Who walks more steps? How many more? Here's the information one more time. Andre walks 6,000 steps in 50 minutes. And the equation Priya uses is y, or the number of steps, equals 118 times x, or 118 times the number of minutes. They're going to walk 5 hours, and 5 hours equals 60 minutes times 5. That means that 5 hours equals a total of 300 minutes. 300 minutes divided by 50 minutes equals 6. So I know that 50 times 6 equals 300. Since we multiplied the number of minutes by 6, we need to multiply the number of steps by 6. 6,000 steps times 6 equals 36,000 steps. For Andre, that's 36,000 steps in 300 minutes, or 36,000 steps in 5 hours. In Priya's equation, x represents the number of minutes, and since she's going to be walking 300 minutes, we need to multiply 118 times 300 minutes. 118 times 300 is 35,400. For Priya, that's 35,400 steps in 300 minutes, or 35,400 steps in 5 hours. Andre walks the most steps. Andre's 36,000 steps minus Priya's 5,400 steps means Andre walked 600 more steps than Priya. Problem number 3, from 8th grade, Unit 2, Lesson 11. Find the coordinates of point D in each diagram. They've given us just enough information that we can figure out the exact location or the coordinates for point D. The obvious information is point D is located on the y-axis. That means that it started at the origin and did not move to the right or to the left along the x-axis. So the x value for point D would be 0. The trick is finding the y value. How far up the y-axis is D? If you look close enough, you'll notice that there are 2 similar triangles. I highlighted one triangle in purple. It has the coordinates 0, 0, -6, and 0. For point D, the coordinates are 0 and unknown. I'm going to show you how to use these coordinates in just a moment. But first, I need to highlight the second triangle. this blue triangle is similar to the purple triangle, and its coordinates are 2 and 0, -6 and 0, and 2 and 10. I can use these ordered pairs or coordinates to help me figure out the side lengths of these two triangles. And in doing so, I'll be able to figure out this missing side length. That'll help me figure out the coordinates for point D. The coordinates of the blue triangle that says 2 and 10 tells me that this side length is 10 units tall. And to figure out the length of the base of this blue triangle, I'd have to figure out the length of the purple triangle's base, which is the absolute value of 6, or 6, plus another length of 2, and the blue triangle has a base length of 8. That's a length of 6 for the purple triangle and a length of 8 for the blue triangle. This tells me that the side lengths of the purple triangle will be 6/8 of the side lengths of the blue triangle. The missing y-coordinate for D will be 6/8 the size of the corresponding y value, which is 10. So 6/8 of 10 equals D. 6/8 of 10 is 60 over 8. And 60 over 8, or 60 divided by 8, equals 7 5/10, or 7 1/2. It just occurred to me that 6/8 is the same as 3/4. So I could have just said 3/4 of 10 is 7 1/2. The coordinates for D are 0 and 7 5/10. Use the same exact strategy to find point D on the right, except for this triangle is elevated above the y-axis. Add the side length of the triangle to the distance between the triangle and the x-axis, and you'll have the location of the y-coordinate for point D. The side length for the blue triangle is 4 units. The base length of the purple triangle is 4 units. The coordinates on the lower right-hand corner tell me that this little section is worth 2, so 4 plus 2 equals 6. The base length of the blue triangle is 6 units. The base length of the purple triangle is 4/6 shorter than the base length of the blue triangle. That means that all the sides of the purple triangle will be 4/6 shorter than their corresponding sides. To account for the space between the x-axis and the triangle's base, I wrote this equation. D equals 3 plus 4/6 of 4, or 3 plus 2/3 of 4, which means 3 plus 2/3 times 4, or 3 plus 2/3 times 4 over 1, which is 8 over 3 times 1. D equals 3 plus 8/3. 8/3 is equivalent to 2 2/3, and 3 plus 2 2/3 is 5 2/3. So D equals 5 2/3. It's not really D equals 5 2/3. It's the y value for point D equals 5 2/3. So the x value is 0 and the y value is 5 2/3. Problem number 4 from 8th grade, Unit 2, Lesson 11. Select all the pairs of points so that the line between those pairs has slope 2/3. A. 0, 0, and 2, 3. Coordinate y2 minus coordinate y1 over coordinate x2 minus x1. That would be 3 minus 0 over 2 minus 0. So we have 3 halves, 3 over 2. It's supposed to be 2 over 3, so that doesn't work. B, 0, 0, and 3, 2. So we have 2 minus 0 over 3 minus 0. That would be 2/3. So B qualifies. C, coordinates 1 and 3, and coordinates 4 and 7. That would be 7 minus 5 over 4 minus 1. That's 2/3, so that would work. C qualifies. D, -2 and -2, and 4 and 2. 2 and the opposite of -2, and 4 and the opposite of -2. So that would be 2 plus 2 and 4 plus 2. That would be 4/6, and that could be simplified or reduced to 2/3. So this one also qualifies. E, 20 and 30, and -20 and -30. So that would be -30 minus 30 and -20 minus 20. That's a total of -60 over -40. A negative divided by a negative is a positive, and 60/40ths can be simplified or reduced to 6/4, which also can be reduced or simplified to 3/2. E does not qualify. Like, comment, share, and subscribe. Open up resources. Illustrative Mathematics, Unit 3, Lesson 5. Introduction to Linear Relationships. Glossary terms. Linear relationship. A linear relationship between two quantities means they are related like this. When one quantity changes by a certain amount, the other quantity always changes by a set amount. In a linear relationship, one quantity has a constant rate of change with respect to the other. The relationship is called linear because its graph is a line. The graph shows a relationship between a number of days and a number of pages read. When the number of days increases by 2, the number of pages read always increases by 60. The rate of change is constant, 30 pages per day, so the relationship is linear. Rate of change. The rate of change in a linear relationship is the amount y changes when x increases by 1. The rate of change in a linear relationship is also the slope of its graph. In this graph, y increases by $15 when x increases by 1 hour. The rate of change is $15 per hour. Let's look at the slope of this line. Let's start at the point in the lower left-hand corner and move to the point in the upper right-hand corner. You have to move to the right 4 units and then move up 60 units. 60 over 4, that's the slope, or 60 divided by 4, which is 15, so the slope of this line is 15. Slope. The slope of a line is a number we can calculate using any 2 points on the line. To find the slope, divide the vertical distance between the points by the horizontal distance. The slope of this line is 2 divided by 3, or 2/3. The slope of a line is rise over run, and in this case the rise is 2 units and the run is 3 units. The slope of this line is 2/3. Problem number 1. A restaurant offers delivery for their pizzas. The total cost is a delivery fee added to the price of the pizza. One customer pays $25 to have 2 pizzas delivered. Another customer pays $58 for 5 pizzas. How many pizzas are delivered to a customer who pays $80? Some of the key information is $25 for 2 pizzas, $58 for 5 pizzas, and a question mark or an unknown amount of pizzas for $80. But they don't tell us the cost for delivery. The cost for delivery is unknown. 2 pizzas plus the delivery fee equals $25. 5 pizzas plus the delivery fee equals $58. 2 pizzas plus delivery equals $25, or 2p plus d equals 25, and 5p plus d equals 58. Since the delivery fee is unknown, we need to get the d by itself. I can rewrite these equations as d equals 25 minus 2p and d equals 58 minus 5p. I want to just test this out and plug some values in for p. Imagine the price of each pizza is $10. So if the price of each pizza was $10, 2 pizzas would be $20, and 5 pizzas would be $50. So 25 minus 20 equals 5, and 58 minus 50 equals 8. One delivery fee came out to $5, the other delivery fee came out to $8. So we know that the price of the pizza is not $10 because the delivery fee is the same every single time. So let's try $11 for the pizza. 2 pizzas times 11 is 22, and 5 pizzas times 11 is 55. So 25 minus 22 is 3, and 58 minus 55 is also 3. So we've figured it out. The delivery fee is $3, and the price of a single pizza is $11. Now we can use this information to figure out how many pizzas are delivered to a customer who pays $80. So $80 minus $3 for delivery equals $77 for pizza, and 77 divided by 11 is 7. So $80 paid for 7 pizzas to be delivered. Problem number 2. To paint a house, a painting company charges a flat rate of $500 for supplies, plus $50 for each hour of labor. A. How much would the painting company charge to paint a house that needs 20 hours of labor? A house that needs 50 hours of labor. 20 hours labor times $50 plus $500 for supplies. 20 times 50 is 1,000 plus $500 is $1,500 or $1,500. 50 hours labor times $50 plus $500 for supplies. 50 times 50 is 2,500 plus 500 is 3,000. Here's a closer look at where those 2 points fall on the grid. 20 units to the right along the horizontal axis and 1,500 units up along the vertical axis for the first point, and 50 units to the right along the horizontal axis and 3,000 units up along the vertical axis. B. Draw a line that represents the relationship between x, the number of hours it takes the painting company to finish the house, and y, the total cost of painting the house. Label the 2 points from the earlier question on your graph. We'll draw a line straight through these 2 points. Notice that the line meets the vertical axis at $500. That $500 is the flat rate for supplies. The first point's coordinates are 20 and 1,500, and the second point's coordinates are 50 and 3,000. C. Find the slope of the line. What is the meaning of the slope in this context? The slope is rise over run. The distance traveled horizontally from 20 to 50 is 30, so the run is 30, and the distance traveled between 1,500 and 3,000 is 1,500, so the rise is 1,500. The slope is 1,500 over 30, or 1,500 divided by 30. And 1,500 divided by 30 is 50, so the slope is 50. The meaning of the slope in this context is the amount of money that the company charges for labor per hour. Problem number 3 from 8th grade, Unit 3, Lesson 4. Tyler and Elena are on the cross-country team. Tyler's distance and times for a training run are shown on the graph. Elena's distance and times for a training run are given by the equation y equals 8 5/10 times x, where x represents distance in miles and y represents time in minutes. A. Who ran farther in 10 minutes? How much farther? Explain how you know. The graph shows that Tyler runs 1 mile in 8 1/3 minutes, which is equal to 8 minutes and 20 seconds. In order to find out how far they ran in 10 miles, we need to find out how far they ran in 1 mile, and then multiply that by 10. 8 1/3 minutes is equivalent to 25/3 of a minute, so he can run 1 mile in 25/3 of a minute. We're going to use this information to see how far he runs in just 1 minute. 25/3 times its reciprocal, 3/25, equals 1. Since we multiplied the minutes by 3/25, we need to multiply the miles by 3/25. And 1 mile times 3/25 equals 3/25. So he can run 3/25 of a mile in 1 minute. We need to know how far he runs in 10 minutes. So 1 minute times 10 equals 10 minutes, and 3/25 times 10 equals 30/25. And 30/25 equals 1 5/25, or 1 1/5 miles. In 10 minutes, Tyler can run 1 1/5 miles. The equation that represents Elena's distance tells us that Elena runs 1 mile in 8 5/10 minutes. which is the same as 8.5 minutes, but I can use 8 5/10. Again, we need to figure out how far she runs in 1 minute. 8 5/10 is the same as 85/10. Multiply 85/10 by its reciprocal, 10/85, to get 1. And since we multiplied the minutes by 10/85, we need to multiply the distance by 10/85. And 1 mile times 10/85 equals 10/85 miles. So that's 1 minute. We need to multiply that by 10 to make it 10 minutes. And 10/85 miles times 10 equals 185 miles. So how far is 185 miles? 85 goes into 100 once with 15 left over. So it's 1 15/85 miles, which is approximately 1 1800 miles. In 10 minutes, Tyler can run 1.2 miles, and in 10 minutes, Elena can run 1.18 miles. Tyler ran farther, and he ran 200 miles farther. B. Calculate each runner's pace in minutes per mile. We did so much work in A that we already have that answer. Tyler runs 1 mile in 8 1/3 minutes, or 8 minutes 20 seconds. And Elena runs 1 mile in 8 5/10 minutes, or 8.5 minutes, or 8 minutes 30 seconds. C. Who ran faster during the training run? Explain or show your reasoning. Tyler ran faster because he finished sooner. Problem number 4 from 8th grade, Unit 2, Lesson 12. Write an equation for the line that passes through coordinates 2 and 5 and 6 and 7. I could make a chart to figure this out with the x-coordinate on the left and the y-coordinate on the right. Let's put the 2 and the 5 and the 6 and the 7. Since half of 2 is 1 and 1 plus 4 equals 5, and half of 6 is 3 and 3 plus 4 equals 7, we can say that the y value equals half the x value plus 4. So an equation that could represent these coordinates can be y equals 1/2 x plus 4. Another equation would be y minus 5 over x minus 2 equals 1/2. Like, comment, share, and subscribe. 8th grade Open Up Resources, Illustrative Mathematics, Unit 3, Lesson 6, More Linear Relationships. Problem number 1. Explain what the slope and intercept mean in each situation. A. A graph represents the perimeter y in units for an equilateral triangle with side length x units. The slope of the line is 3 and the y-intercept is 0. I wrote the equation y equals 3x plus 0 to represent this situation. The x-axis represents the side length and the y-axis represents the perimeter. When the side length increases by 1 unit, the perimeter increases by 3 units. Let's put this information in a chart. The left column will be the side length and the right column will be the perimeter. When the side length is 1, the perimeter will be 3. When the side length is 2, the perimeter will be 6. And when the side length is 3, the perimeter will be 9. In this situation, the slope represents the sum of all 3 sides of the triangle. B. The amount of money, y, in a cash box after X tickets are purchased for carnival games. The slope of the line is 1/4 and the y-intercept is 8. I wrote the equation y equals 1/4 x plus 8 to represent this situation. The x-axis represents the number of tickets sold, and the y-axis represents the amount of cash in the cash box. At the start, when 0 tickets were sold, there was $8 in the cash box. After 1 ticket was sold, there was $8.25 in the cash box. After 2 tickets, there was $8.50. After 3 tickets, $8.75. After 4 tickets, $9 were in the cash box. Here's a look at the line with 1/4 slope. I'll put a point in blue to represent 1 ticket sold, 2 tickets sold, 3 tickets sold, and 4 tickets sold. Those 4 tickets show a rise of exactly $1, 4 units to the right and $1 up. The slope of 1/4 means that each ticket costs 1/4 of a dollar or 25 cents. The y-intercept of 8 means that the cash box had $8 in it at the start. C. The number of chapters read, y, after x days. The slope of the line is 5/4 and the y-intercept is 2. I wrote the equation y equals 5/4 x plus 2 to represent this situation. With the y-intercept at 2, 0 days shows that 2 chapters are already completed. By the 4th day, 7 chapters are completed. Start counting the days at the y-intercept. After the 4th day, 5 chapters are completed for a total of 7 chapters. Here's a look at the line with a slope of 5/4 starting at the y-intercept of 2. The slope of 5/4 means that 5 chapters are read every 4 days. The y-intercept means that the first 2 chapters were read beforehand or were skipped. D. The graph shows the cost in dollars y of a muffin delivery and the number of muffins x ordered. The slope of the line is 2 and the y-intercept is 3. I wrote the equation y equals 2x plus 3 to represent this situation. The x-axis represents the number of muffins. The y-axis represents cost in dollars. The y-intercept could represent the charge for delivery. The slope represents the price per muffin. Notice at 0 muffins, the cost in dollars is $3. That's the charge for delivery. Then the cost for 1 muffin is an additional $2, making the cost in dollars for 1 muffin to be delivered a total of $5. Then 2 muffins, the total cost would be $7, and 3 muffins, the total cost for delivery would be $9. There's the look at a line that would have a slope of 2 and a y-intercept of 3. Problem number 2, from 8th grade, Unit 3, Lesson 4. The graph shows the relationship between the number of cups of flour and the number of cups of sugar in Lynn's favorite brownie recipe. The table shows the amounts of flour and sugar needed for Noah's favorite brownie recipe. A. Noah and Lynn buy a 12-cup bag of sugar and divide it evenly to make their recipes. If they each use all their sugar, how much flour do they each need? This means that they'll each be using 6 cups of sugar. Noah's graph shows us that he uses 2 cups of sugar for every 1 cup of flour. And Lynn's table shows us that Lynn uses 3 cups of sugar for every 2 cups of flour. The ratio of sugar to flour for Noah is 2 to 1. 2 cups times 3 equals 6, or 6 cups of sugar. And 1 cup of flour times 3 equals 3 cups of flour. Noah uses 3 cups of flour for every 6 cups of sugar. Look at Lynn's table. 3 cups of sugar times 2 equals 6 cups of sugar. So 2 cups of flour times 2 equals 4 cups of flour. For every 6 cups of sugar that Lynn uses 4 cups of flour. B. Noah and Lynn buy a 10-cup bag of flour and divide it evenly to make their recipes. If they each use all their flour, how much sugar do they each need? 10 divided by 2 equals 5 cups. So each of them will be using 5 cups of flour and an unknown number of cups of sugar. Noah's ratio of flour to sugar is 1 cup to 2 cups. And Lynn's ratio of flour to sugar is 2 cups to 3 cups. 1 cup of flour times 5 is 5 cups, and 2 cups of sugar times 5 is 10 cups of sugar. Noah will use 10 cups of sugar for every 5 cups of flour. Looking at Lynn's table, I've decided to make it a little bit easier by using the ratio of 1 cup of flour to 3 half cups of flour. 1 cup of flour times 5 is 5 cups of flour, and 3 half cups of sugar times 5 is 15 half cups of sugar. And 15 half cups of sugar is the same as 15 divided by 2, which is 7.5 or 7 5/10. For every 5 cups of flour that Lynn uses, Lynn will use 7.5 cups of sugar. So Noah uses 10 cups of sugar and Lynn uses 7.5 cups of sugar. Number 3, customers at the gym pay a membership fee to join and then a fee for each class they attend. Here is a graph that represents the situation. A. What does the slope of the line shown by the points mean in this situation? The horizontal axis is the number of classes, and the vertical axis is the cost in dollars. The slope of this line means that the cost for each class is $20. B. What does the vertical intercept mean in this situation? In this situation, the y-intercept represents the membership fee. Eighth grade, Unit 3, Lesson 7, Representations of Linear Relationships. Problem number 1, from 8th grade, Unit 3, Lesson 4. Here are recipes for 2 different banana cakes. Information for the first recipe is shown in the table. The relationship between cups of flour, y, and cups of sugar, x, in the second recipe is y equals 7/4 times x. This table represents the first recipe, and this equation represents the second recipe. A. If you used 4 cups of sugar, how much flour does each recipe need? The left-hand column of this table represents x, and the right-hand column of this table represents y. To get 4 cups of sugar, I'd have to multiply 1/2 a cup of sugar times 8. And if I multiply the x column by 8, I need to multiply the y column by 8. So 1/2 times 8 is 4, and 3/4 times 8 is 6. In the first recipe, for every 4 cups of sugar, there are 6 cups of flour. In the second recipe, y represents the number of cups of flour. So the number of cups of flour will equal 7/4 times x, or 7/4 times 4, if there's 4 cups of sugar. And 7/4 times 4 is the same as 7/4 times 4 over 1, which is 28/4, or 28 divided by 4. And 28 divided by 4 is 7. So in the second recipe, for every 4 cups of sugar, there are 7 cups of flour. In the first recipe, for 4 cups of sugar, you would have 6 cups of flour, and in the second recipe, for 4 cups of sugar, you'd have 7 cups of flour. B. What is the constant of proportionality for each situation, and what does it mean? For the first recipe, we can divide 3/4 by 1/2, which is 1.5. So the constant of proportionality for the first recipe is 1.5. 1 cup of sugar to 1.5 cups of flour. For the second recipe, we can divide 7 by 4. 7 divided by 4 equals 1 3/4. So for the second recipe, the constant of proportionality is 1 3/4, which means for every 1 cup of sugar, there's 1 3/4 cups of flour. Problem number 2, from 8th grade, Unit 2, Lesson 6. Show that the 2 figures are similar by identifying a sequence of transitions, rotations, reflections, and dilations that takes the larger figure to the smaller one. Let me show you a quick animation, and then I'll tell you what I did. First, translate point H to point D. Second, reflect across a vertical line at point D, and last, dilate using a half-scale factor using point D as center. Problem number 3. Create a graph that shows 3 linear relationships with different y-intercepts using the following slopes, and write an equation for each line. The first slope is 1/5. Let's start writing the equation with y equals 1/5 times x, and then let's make the y-intercept 1. So now the equation would read y equals 1/5 times x plus 1. We could put some points on this line. Let's go up 1 and over 5. There's another point. Let's go up 1 and over 5 again. There's another point. And here's a look at the line that has a slope of 1/5. The second slope is 3/5. So let's start out with y equals 3/5 times x. And let's make the y-intercept 3. So now the equation reads y equals 3/5 times x plus 3. Let's put another point by going up 3 and over 5. There's another point. Let's go up 3 and over 5 for a third point. And here's a look at a line that has a slope of 3 over 5. And the last slope is 6 over 5. Let's start the equation with y equals 6 over 5 times x. Let's make this y-intercept 2. So now the equation would read y equals 6 over 5 times x plus 2. Let's add some points to this graph by going up 6 and over 5. There's a location of another point. Let's go up 6 and over 5. And there's our third point. Now here's a look at a line that has a slope of 6 over 5. Problem number 4. The graph shows the height in inches, h, of a bamboo plant t months after it has been planted. A. Write an equation that describes the relationship between h and t. The vertical axis h is like the y-axis, and the horizontal axis t is like the x-axis. When we write the equation y equals the slope times x plus the y-intercept, we can substitute the y and the x with the h and the t. Now it reads h equals slope times t plus y-intercept. And the y-intercept is 12. So the equation would read h equals slope times t plus 12. Since the rise is 15, counting by 5s, and the run is 5, counting by 1s, the slope is 15 over 5, which is the same thing as 15 divided by 5, or 3. Now I just noticed a misprint down at the bottom of this graph in t months. It says 5, 5 when it should say 5, 6, so I'll fix that. I'll substitute the slope for 15 over 5, or 3, and now the equation reads h equals 3 times t plus 12. The equation that represents the relationship between h and t is h equals 3t plus 12. B. After how many months will the bamboo plant be 66 inches tall? Explain or show your reasoning. I'm going to substitute the h, or height in inches, with 66. Now the equation reads 66 equals 3 times t plus 12, or 66 equals 3t plus 12. To solve for t, we have to take away 12 from both sides. 12 minus 12 is 0, and 66 minus 12 is 54. So now the equation reads 54 equals 3 times t. To make the t just 1 t, we have to divide by 3. Since we've divided the time by 3, we need to divide the inches by 3. So 3 divided by 3 is 1, and 54 divided by 3 is 18.
like, comment, share, and subscribe.
8th grade Open Up Resources, Unit 3, Lesson 8, Translating to y equals mx plus b. Number 1, select all equations that have graphs with the same y-intercept. For each of these, the y-intercept is the last term in the equation. For A, the y-intercept is -8. And for D, E, and F, the y-intercept is also -8. So A, D, E, and F all have the same y-intercept. Problem number 2. Create a graph showing the equations y equals 1/4 x and y equals 1/4 x minus 5. Explain how the graphs are the same and how they are different. First, let's graph y equals 1/4 x. And in this case, b is 0. So this could read y equals 1/4 x plus 0. M, or the slope, is represented by 1/4. So we need to rise up 1 because it's a positive 1. And we need to run to the right 4 units because it's a positive 4. And I can mark that spot with a point. And from that point, I can move 1 unit up and 4 units to the right and put another point. You see it lands on the line each time. So this line represents 1/4 x plus 0. Let's work on the line for y equals 1/4 x minus 5. Minus 5, or -5, is the y-intercept. So let's start at the y-intercept and move up 1 and then to the right 4 units. That's where we can put our first point. Move up 1 again and 4 units to the right, and that's where we can put another point. And you can see that these points land on this line. So this line represents y equals 1/4 x minus 5. Problem number 3. A cable company charges $70 per month for cable service to existing customers. A. Find a linear equation representing the relationship between x, the number of months of service, and y, the total amount paid in dollars by an existing customer. They tell us that y equals the total amount paid in dollars by an existing customer. So y equals 70 times x, with the x representing the number of months of service. B. For new customers, there's an additional one-time $100 service fee. Repeat the previous problem for new customers. This equation will be exactly the same as the first equation with one exception. There's a $100 service fee. That $100 service fee is going to represent the y-intercept. So the equation will read y equals 70 times x plus 100. C. When the two equations are graphed in the coordinate plane, how are they related to each other geometrically? The two lines would be parallel because they'd have the same slope. The line for A would have a y-intercept of 0, and the line for B would have a y-intercept of 100. Problem number 4 from 8th grade, Unit 3, Lesson 6. Match each graph to a situation. Graph A has a y-intercept of 8 and a slope of 1/4. So we have to find the situation that would have a y-intercept of 8 and or a slope of 1/4. In situation number 2, I found the slope of the line is 1/4. So situation number 2 matches up with graph A. Let's take a look at graph B. The y-intercept for graph B is 3. Let's find the slope of this line. The rise is 2 and the run is 1. So that would be 2/1, and 2/1 is 2 divided by 1, or 2. Let's look for a situation that has a y-intercept of 3 and or a slope of 2. The slope of the line for graph number 4 is 2. Graph B matches up with situation number 4. Graph C has a y-intercept at the origin, so the y-intercept for graph C would be 0. It has a rise of 3 and a run of 1. 3 over 1 is 3, so it has a slope of 3. Let's look for a situation that has a y-intercept of 0 and or a slope of 3. Look at situation number 1. The slope of the line is 3. Graph C matches up with situation number 1. Let's look at graph D. Graph D has a y-intercept at the origin, so the y-intercept would be 0, and the slope is 5 over 4. So we're looking for a situation that has either the y-intercept of 0 or a slope of 5/4. The slope of the line is 5/4 for situation number 3. Graph D matches up with situation number 3. Problem number 5 from 8th grade, Unit 3, Lesson 6. A mountain road is 5 miles long and gains elevation at a constant rate. After 2 miles, the elevation is 5,500 feet above sea level. After 4 miles, the elevation is 6,200 feet above sea level. A. Find the elevation of the road at the point where the road begins. This line represents the road, and after 2 miles, you can see the elevation is 5,500 feet. After 4 miles, the elevation is 6,200 feet. The difference between 6,200 feet and 5,500 feet is 700 feet. 6,200 feet minus 700 feet is 5,500 feet, and 5,500 feet minus 700 feet is 4,800 feet. The road starts at 4,800 feet. B. Describe where you would see the point in part A on a graph where y represents the elevation in feet and x represents the distance along the road in miles. As you can see, I've written the coordinates above, 0 and 4,800. The road would begin at 0 on the x-axis, and it would begin at 4,800 on the y-axis.
8th grade Open Up Resources, Illustrative Mathematics, Unit 3, Number 1. Suppose that during its flight, the elevation e in feet of a certain airplane and its time t in minutes since takeoff are related by a linear equation.
Consider the graph of this equation with time represented on the horizontal axis and the elevation on the vertical axis. For each situation, decide if the slope is positive, 0, or negative. A. The plane is cruising at an altitude of 37,000 feet above sea level. Since the plane is cruising at 37,000 feet and there is no change in the rise, this is a 0 slope. The slope is 0. B. The plane is descending at a rate of 1,000 feet per minute. The rise goes down along the y-axis and to the right along the x-axis. This means that the rise is negative and the run is positive. This means it has a negative slope. The slope is negative. C. The plane is ascending at a rate of 2,000 feet per minute. The rise moves up and the run moves to the right, so the rise is positive and the run is positive. This makes a positive slope. The slope is positive. Problem number 2. A group of hikers park their car at a trailhead and hike into the forest to a campsite. The next morning, they head out on a hike from their campsite, walking at a steady rate. The graph shows their distance in miles, d, from the car on the day of their hike after h hours. A. How far is the campsite from their car? Explain how you know. I labeled the horizontal axis hours and the vertical axis distance. The origin represents where they parked the car, and the y-intercept represents their campsite. Some key information that they told us in the paragraph is the hike into the forest to a campsite. Start at the origin and count up until you hit the y-intercept. Here you can see the y-intercept is 4, so the campsite is 4 miles away from their car. B. Write an equation that describes the relationship between D and H, distance and hours. Well, I know that the distance equals the 4 miles to the campsite plus 3 times H, because the slope of this line is 3. The rise is 3 and the run is 1, and 3 divided by 1 is 3. Another equation that represents the relationship between D and H is D equals 3H plus 4. 3 represents the slope and 4 represents the y-intercept. C. After how many hours will the hikers be 16 miles from their car? Explain or show your reasoning. Count from the origin 4 miles to the campsite, and then continue counting vertically along the y-axis until you reach 16 miles. Since the slope is 3, every 3 miles after the y-intercept represents 1 hour's worth of hiking. So far after the y-intercept, we've gone 3 miles in blue. Now we've gone 6 miles in blue. That would represent 2 hours. Now we're at the 9-mile mark, which would represent 3 hours. And finally, we reach 12 miles after the y-intercept, which means 12 miles after the first 4 miles to the car, for a total of 16 miles. So it would take a total of 4 hours for the hikers to be 16 miles from their car. Number 3. Elena's aunt pays her $1 for each call she makes to let people know about her aunt's new business. The table shows how much money Diego receives for washing windows for his neighbors. Select all the statements about the situation that are true. A. Elena makes more money for making 10 calls than Diego makes for washing 10 windows. Well, I know that Elena would make $10 for making 10 calls. Now let's look at the chart to see how much Diego makes washing windows. The column on the left shows the number of windows, and the column on the right shows the number of dollars. So let's look at the top row of this table. 27 windows earns Diego $30. So he's making more than $1 per window, which means that he's making more money per window than Elena makes per call. So statement A is not true. So I'm not going to select statement A. Statement B. Diego makes more money for washing each window than Elena makes for making each phone call. We've already decided that that's true, but let's take a look at the top row. 27 windows compared to $30. 27 is less than 30. Or $30 compared to 27 windows. 30 is greater than 27. So Diego makes more dollars per window than Elena makes per phone call. So yes, statement B is true, so I would select statement B. Statement C. Elena makes the same amount of money for 20 calls as Diego makes for 18 windows. I'll make a chart so we can do a side-by-side comparison between Elena and Diego. We know that Elena earns $1 for making 1 phone call. At that rate, if she made 45 phone calls, she would earn $45. If she made 20 phone calls, she'd make $20. Let's figure out how much Diego makes for 1 window. 27 divided by 27 equals 1, and 30 divided by 27 equals 30 over 27. So Elena earns $20 for making 20 calls. Let's see how much Diego earns for washing 18 windows. 1 times 18 equals 18, and 30 over 27 times 18 equals 20. So Diego earns $20 for washing 18 windows, which is equal to the amount of money that Elena earns making 20 phone calls. Yes, this statement is true, so I would also select statement C. Statement D. Diego needs to wash 35 windows to make as much money as Elena makes for 40 phone calls. Elena makes $40 for making 40 phone calls. What does Diego earn for washing 35 windows? Diego gets paid 30 over 27 per window. So 30 over 27 times 35 equals approximately $38.89. In case you're wondering, 30 over 27 or 30 divided by 27 equals just a little bit over $1.11. So a little bit more than $1.11 times 35 equals just about $38.89. So Diego earns about $38.89 for washing 35 windows. No, Diego needs to wash more than 35 windows to earn as much as Elena when she makes 40 phone calls, so I won't select statement D. E. The equation y equals 9/10 x, where y is the number of dollars and x is the number of windows, represents Diego's situation. Let's use my bottom row in Diego's table and substitute the 20 for D and substitute 18 for x. Now I have an equation that reads 20 equals 9/10 times 18. Let's see if this is true. 9 times 18 equals 162, and 10 times 1 equals 10. 162 over 10 is equivalent to 16 2/10, and 20 does not equal 16 2/10. So this statement is not true. I will not choose statement E. Statement F. The equation y equals x, where y is the number of dollars and x is the number of calls, represents Elena's situation. Let's use the bottom row of Elena's table and substitute y, or the number of dollars, with 20, and substitute x, or the number of calls, with 20. And yes, 20 does equal 20, so this statement is true. I will select statement F. Problem number 4. Each square on a grid represents 1 unit on each side. Match the numbers with the slopes of the lines. Let's start with a line on graph A. I need to find perfect places to place some points to help me find the slope. This looks like a good spot, and this looks like a good spot. I'll place points on each of these 2 locations. I rise up 4 units, and I run 1 unit. That's a slope of 4 over 1, and 4 over 1 equals 4. The slope for the line on graph A is 4. Let's take a look at the line on graph B and find locations to put 2 points. These 2 locations are perfect locations to put points to find the slope. I'm going to rise up 1 and run to the right 4. That's a slope of 1/4. The line on graph B has a slope of 1/4. Let's take a look at the line on graph C. First, I need to find the perfect places to put points to help me find the slope. These 2 locations are good places for me to put points to help me find the slope of this line. The rise is down 1, or -1, and the run is 4 places to the right, or +4. So the slope of the line on graph C is -1/4.
Like, comment, share, and subscribe.
8th grade, Unit 3, Lesson 10, Calculating Slope. Problem number 1. For each graph, calculate the slope of the line. We have to remember that the slope equals the difference of the y-coordinates over the difference of the x-coordinates, or y minus y divided by x minus x. You can do this either way, y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. If you don't understand it quite yet, don't worry, I'll show you what I mean. Let's put a point for this set of coordinates, 8 and 4, and let's put a point for this set of coordinates, 2 and 6. So y minus y, that would be 4 minus 6, and x minus x, that would be 8 minus 2. 4 minus 6 is -2, and 8 minus 2 is 6. The slope of this line is negative 2 over 6. This means that the rise is negative 2, or the rise goes down 2, and the run is 6. It runs 6 places to the right in the positive direction, which is equivalent to negative 1/3. The rise would go down 1 unit, and the run would go to the right 3 units. Either answer would be correct. The slope of this line is negative 2/6 or negative 1/3. Graph B. Let's put a point for the coordinates 1, 1, and a point for the coordinates negative 5, 7. Y minus y, that would be 1 minus 7, over x minus x, that would be 1 minus a negative 5. 1 minus 7 is negative 6, and 1 minus a negative 5 is the same thing as 1 plus 5. 1 plus 5 is 6. So the slope of this line is negative 6 over 6, which is the same thing as negative 1. This means that the rise goes down 6 units, or negative 6 units, and the run moves to the right, or runs positive 6 units. Graph C, let's put a point at coordinates negative 2 and negative 8, and let's put a point at coordinates negative 6, negative 3. Y minus y, that would be negative 8 minus a negative 3. X minus x, that would be negative 2 minus a negative 6. Negative 8 minus a negative 3 is the same thing as negative 8 plus 3, or negative 5. Negative 2 minus a negative 6 is the same thing as negative 2 plus 6, or 4. The slope for this line is negative 5 over 4. That means down 5 units and runs to the right 4 units. Problem number 2. Match each pair of points to the slope of the line that joins them. We have to remember that the slope equals the difference of the y-coordinates over the difference of the x-coordinates, or y minus y over x minus x. Remember, this could be y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Here we go. A. 2 minus 10 over 7 minus 9. So on top we have the difference of the y values, which is 2 minus 10, or negative 8. And on the bottom we have the difference of the x values, which is 7 minus 9, or negative 2. Since negative 8 divided by negative 2 is 4, the slope of this line is 4. I also could have done it this way. The difference of the y values 10 minus 2 over the difference of the x values 9 minus 7. 10 minus 2 is 8, and 9 minus 7 is 2. 8 divided by 2 is 4. The slope of the line that match these pair of points is 4. The y value negative 5 minus the y value negative 11, that's the same as minus a negative. I like to look at it as the opposite of a negative, and the opposite of a negative is a positive. So negative 5 plus 11 over negative 1 minus negative 8, or negative 1 minus the opposite of negative 8, and the opposite of negative 8 is plus 8. So negative 1 plus 8. Negative 5 plus 11 is 6, and negative 1 plus 8 is 7. So the slope of this line would be 6 over 7. C. 3 minus a negative 6, which would be positive 6, over 2 minus 5. 3 plus 6 is 9, and 2 minus 5 is negative 3. Since 9 divided by negative 3 equals negative 3, then the slope of this line would equal negative 3. D. Negative 1 minus 3 over 5 minus 6. Negative 1 minus 3 equals negative 4, and 5 minus 6 equals negative 1. Negative 4 divided by negative 1 equals positive 4. The slope of this line would be positive 4. E. 2 minus 7 over 6 minus 4. 2 minus 7 equals -5, and 6 minus 4 equals 2. The slope of this line would be -5 over 2. Problem number 3. Draw a line with the given slope through the given point. What other point lies on that line? A. Point A. Slope equals -3. First, I need to locate point A, and since it has a slope of -3, that means the rise is -3 and the run is 1 unit to the right. I can plot more points by going down 3 and to the right 1. Down 3 and to the right 1. Here I can see that point B is also on this line. Here's a look at the line with the -3 slope. B. Point A and the slope equals -1 over 4. Like before, I start at point A, only this time I go down 1 unit and to the right 4 units. Down 1 unit, to the right 4 units. And you can see that point D is also on this line. Here's a look at the line with a -1 over 4 or -1/4 slope. C. Point C. Slope equals -1 over 2 or -1/2. First I need to find point C, then I need to go down 1 unit and to the right 2 units. Down 1 unit, to the right 2 units. I can continue that until I find the other point that's on the line. Here I can see that point E is also on the line, and here's a look at the line with a slope of -1/2. D. Point E. Slope equals -2 over 3. That means that the rise will go 2 units down, and the run will be 3 units to the right. And you can see that point B is also on this line. Here's a look at the line that has a -2/3 slope. Problem number 4, from 8th grade, Unit 3, Lesson 8. Make a sketch of a linear relationship with a slope of 4 and a -y-intercept. Show how you know the slope is 4 and write an equation for the line. The first thing I'll do is put a point somewhere on the y-axis but below the x-axis. This way I know that it will have a -y-intercept. I can start at this point for the y-intercept and move up 4 units and then to the right 1 unit because it has a slope of 4. That would mean that there's a rise of 4 units and a run to the right of 1 unit. So up 4 and to the right 1. Then I can put my next point. I can use these points to sketch a line. So here's a look at a line that has a slope of 4 and a -y-intercept. The equation that I wrote is y equals 4x minus 2. 8th grade, Unit 3, Lesson 11, Equations of all kinds of lines. Problem 1. Suppose you wanted to graph the equation y equals -4x minus 1. A. Describe the steps you would take to draw the graph. I would start by plotting a point 1 unit below the origin on the y-axis. This represents the y-intercept. Next, I would start at that point and count 4 units down and 1 unit to the right. I would plot a point at this location. Last, I would use the 2 points to draw a line that runs through those 2 points. B. How would you check that the graph you drew is correct? I would verify the y-intercept and the slope of the line. I could also substitute coordinates from points on the line into the equation. Problem number 2. Draw the following lines and then write an equation for each. A. Slope is 0, y-intercept is 5. First I'll start by plotting the point for the y-intercept at 5 on the y-axis. And since the slope is 0, it's just a horizontal line that runs through the y-intercept at 5. B. Slope is 2. y-intercept is -1. Again, I'll start by plotting the point for the y-intercept at -1 on the y-axis. Since the slope is 2, from that point, I'll count up 2 and to the right 1 and plot a point. I can continue doing this as many times as I find necessary to help me draw my line. For a slope of 2, I can also count down 2 and to the left 1. Here's a look at the line that has a y-intercept of -1 and a slope of 2. C. Slope is -2, y-intercept is 1. Again, I'll start by putting a point that represents the y-intercept. This is 1 unit above the origin on the y-axis. Since the slope is -2, I can move down 2 and to the right 1. I can do this as many times as I want to plot new points for my line. This green line represents a line with a slope of -2 and a y-intercept of 1. D. Slope is -1/2. Y-intercept is -1. I'll start by plotting a point for the y-intercept, which is -1 on the y-axis. And since the slope is -1/2, I can start at that point and move down 1 and to the right 2 as many times as I need to plot new points. This purple line represents a line with a y-intercept of -1 and a slope of -1/2. Problem 3. Write an equation for each line. Let's start with the red horizontal line. I'm going to put a point that represents the y-intercept. Since this is a horizontal line without a positive or a negative slope, and the y-intercept is 4, I can write an equation that reads y equals 0 times x plus 4. Or I can write the equation y equals 4. Because no matter where you are on this line, the y value will be 4. Look at the vertical green line. It runs through the x-axis at -1. So x equals -1. Because no matter where you are on this green line, the x value will always be -1. Let's look at the horizontal blue line. The y-intercept is -2. So no matter where you are on the blue line, the y value will always be -2. Y equals -2. And finally, let's look at the vertical yellow line. The vertical yellow line runs through the x-axis at 6. So no matter where you are on this yellow line, the value for x will always be 6. X equals 6. Problem number 4 from 8th grade, Unit 3, Lesson 7. A publisher wants to figure out how thick their new book will be. The book has a front cover and a back cover, each of which have a thickness of 1/4 of an inch. They have a choice of which type of paper to print the book on. A. Bond paper has a thickness of 1/4 inch per 100 pages. Write an equation for the width of the book y if it has x 100 pages printed on bond paper. The variable y represents the thickness of the book. The front cover is 1/4 of an inch, the back cover is 1/4 of an inch, so far the thickness of the book is 1/2 inch. We also have to include the thickness of the bond paper, and it says bond paper is 1/4 inch thick per 100 pages. The equation would read y equals 1/2 plus 1/4 x, or the equation could read y equals 1/4 x plus 1/2. B. Ledger paper has a thickness of 2/5 of an inch per 100 pages. Write an equation for the width of the book y if it has x 100 pages printed on ledger paper. The thickness of the front cover and back cover combined is still 1/2 inch. So the only term that will change will be the amount multiplied by x. Instead of 1/4 x, we'll have 2/5 x. So y equals 2/5 x plus 1/2. C. If they instead choose front and back covers of thickness of 1/3 of an inch, how could this change the equations in the previous two parts? This would change the term that represents the thickness of the book. So for the first equation, it would change to y equals 1/4 x plus 2/3, and the second equation would change to y equals 2/5 x plus 2/3. 8th grade Unit 3, Lesson 12, Solutions to Linear Equations. Before we get into this, hit that like button. I appreciate it. Problem number 1. Select all the ordered pairs x and y that are solutions to the linear equation 2x plus 3y equals 6. Let's take a look at the first set of ordered pairs and substitute 0 for the x variable and 2 for the y variable. That would be 2 times 0 plus 3 times 2 equals 6. 2 times 0 is 0, and 3 times 2 equals 6. 0 plus 6 equals 6, so A is a solution for the linear equation. Let's do the same thing for B. Substitute a 0 for the x and a 6 for the y. 2 times 0 equals 0 plus 3 times 6. 3 times 6 is 18, and 0 plus 18 equals 18. Since the linear equation equals 6 and the ordered pairs for B equal 18, the ordered pairs for B are not a solution. C. Substitute the x with a 2 and substitute the y with a 3. So it would read 2 times 2 plus 3 times 3. That would be 4 plus 9, which is equal to 13, not 6, so C is not a solution. D. Substitute the x with a 3 and the y with a negative 2. So it reads 2 times 3 plus 3 times negative 2. 2 times 3 is 6, and 3 times negative 2 is negative 6. So that's like 6 plus a negative 6, or 6 minus 6, which is 0. So D is also not a solution. E. Substitute the x with a 3 and substitute the y with a 0. 2 times 3 plus 3 times 0. 2 times 3 is 6, and 3 times 0 is 0, so 6 plus 0 equals 6, so the ordered pairs for E are a solution. F. Substitute the x with the 6 and the y with the negative 2. It would read 2 times 6 plus 3 times a negative 2. 2 times 6 is 12, and 3 times a negative 2 is a negative 6, so that's like 12 plus a negative 6, or 12 minus 6, and 12 minus 6 is 6. The ordered pairs for F are also a solution to the linear equation. Problem number 2. The graph shows a linear relationship between x and y. X represents the number of comic books Priya buys at the store, all at the same price, and y represents the amount of money in dollars Priya has after buying the comic books. A. Find and interpret the x and y intercepts of this line. The horizontal axis, or the x-axis, represents the comic books, and the vertical axis, or the y-axis, represents dollars. The x-intercept is located at the 5 on the x-axis, and the y-intercept is located at the 20 on the y-axis. These intercepts tell me that Priya has $20, and if she buys 5 comics, she will spend all her money. B. Find and interpret the slope of this line. I'll start at the y-intercept, and I'll count down 5, 10, 15, 20. That's down 20, or negative 20. And to the right, 1, 2, 3, 4, 5. That's 5 to the right. Negative 20 divided by 5 equals negative 4. The slope of this line is negative 4. C. Find an equation for this line. Y equals negative 4x plus 20, or y equals 20 minus 4x. This means that the value for y will be equal to the slope, or negative 4 times the value for x, plus the y-intercept, which is 20. D. If Priya buys 3 comics, how much money will she have remaining? I'll use the equation y equals negative 4 times x plus 20 to help me write this equation, but I'm going to substitute the x with the number of comics. So the equation will read y equals negative 4 times 3 plus 20. And negative 4 times 3 is negative 12. So the value for y will equal 20 minus 12. And 20 minus 12 is 8. So y equals 8, or the amount of dollars that she will have remaining equals 8. Number 3. Match each equation with its 3 solutions. A. Y equals 1.5 times x. Let's use the first pair in number 1, 14 and 21. Since 14 times 1.5 equals 21, if y were 21, then 1.5 times 14 equals 21. Let's look at the next pair, 2 and 3. 2 times 1.5 equals 3. So that also works. And 8 times 1.5 equals 12. All 3 sets for number 1 are a solution for A. B. 2x plus 3y equals 7. Substitute the -1 for x and the 3 for y, and you have 2 times -1 plus 3 times 3 equals 7. A -2 and a +9 is the same as 9 and a -2, which is 9 minus 2, or 7. I used the ordered pair -1 and 3 from number 4. All the other ordered pairs in number 4 also work. Equation B is a match with number 4 solutions. C. X minus y equals 4. -1 minus -5 equals 4. Minus a -5 is like the opposite of -5, or plus 5. So this would read -1 plus 5 equals 4, or 5 minus 1 equals 4. You'll find the solution that has a -1 and a -5 in the solutions for number 2. Equation C is a match for the number 2 solutions. D. 3x equals y divided by 2. 3 times 1 equals 6 divided by 2. 3 times 1 is 3, and 6 divided by 2 is 3. 3 equals 3. The ordered pair with a 1 and a 6 can be found in the number 5 solutions. Solution number 5 is a match with equation D. E. Y equals x plus 1. 1/2 equals -1/2 plus 1. -1/2 plus 1 is the same as 1 minus 1/2. 1/2 equals 1 minus 1/2. 1/2 equals 1/2. The ordered pairs 1/2 and 1/2 are found in solution 3. Solution number 3 is a match with equation E. Problem number 4. A container of fuel dispenses fuel at the rate of 5 gallons per second. If y represents the amount of fuel remaining in the container, and x represents the number of seconds that have passed since the fuel started dispensing, then x and y satisfy a linear relationship. In the coordinate plane, will the slope of the line representing that relationship have a positive, negative, or 0 slope? Explain how you know. I've created a graph with the seconds along the horizontal axis, or the x-axis, and gallons along the vertical axis, or the y-axis. The line shows that as the seconds pass, the gallons decrease, and it does so at a rate of 5 gallons per second. The rise goes down 5 gallons and to the right 1 second. This is a negative slope because the amount of fuel in the tank is decreasing. Problem number 5. A sandwich store charges a delivery fee to bring lunch to an office building. One office pays $33 for 4 turkey sandwiches. Another office pays $61 for 8 turkey sandwiches. How much does each turkey sandwich add to the cost of the delivery? Explain how you know. This represents the 4 turkey sandwiches ordered by the first office building, and this represents the 8 turkey sandwiches ordered by the second office building. The first office building paid $33 for delivery and 4 sandwiches. The second office building paid $61 for 8 sandwiches and the delivery. If I take away $33 from $61, that's like taking away the delivery fee and the price of 4 sandwiches. That would leave me with just the price of 4 sandwiches. The $61 paid by the second office building minus $33 paid from the first office building is $28. These 4 sandwiches cost $28. 28 divided by 4 equals 7. The price of each sandwich is $7. Each sandwich costs $7. Subtract the total price of 4 sandwiches and the delivery fee, and you're left with 4 sandwiches for $28. And $28 divided by 4 sandwiches is $7 per sandwich.
Please take a moment to help support my channel by liking this video, commenting on this video, sharing this video, and subscribing to my channel. Thanks. I appreciate it.